So basically, for VDB, we added in asynchronous server into the command line, and again, we use Python to be able to extend the handlers as needed. And so anyone that's familiar with the framework or understands how to write the plugins can actually go through and write the plugins. And again, you can also do it to the point where you could just load it in using the Python interface. So that brings us to the bastard child of them all, WinDbg. So WinDbg, when I started working, didn't really have a Python interface that I could actually load in as a plugin. So currently, it's only implemented in C++. So it's incredibly difficult to add it's more difficult to add new commands and make everything work and talk very quickly without having to go through recompile and testing all the time. But it does have the asynchronous server, which we also pulled from another open source project by DEFCON, by Linux and Pusscat. So,
so basically, we got all this stuff going. It's still an iterative process, but we have a few lessons that we learned from it. Basically, as Adam said a lot, we like high-level languages. You know, I'm a native C programmer, but I appreciate that when you're trying to get something done, Python or Ruby or something makes things a lot easier. Documentation is not always useful. Sometimes it can be, but make sure you find examples and source code and just ping people when things aren't working. Don't waste too much time, believing that the documentation is right and that you're doing something wrong, because sometimes there's a gap. Write scripts to make things as automated as possible. Spend time, thinking about what the model is and what you're really trying to do, and implement iteratively and understand iteratively. Don't try to build one big monolithic thing, solve little problems, then try to piece your code together.
Yeah, the key thing is look for small milestones that you can accomplish over a long period of time. Because the more small milestones that you can pile up or that you can complete, over a few days or a few weeks, the more likely you'll move towards something. As you start building out, as you start dreaming big and start saying, I'm going to implement all of this in one sitting, you start to become a little bit more bogged down because you're becoming more concerned with, oh, I'm not getting this done, or I'm falling behind, and then it starts to propagate, or it starts to become a little bit more cumbersome to deal with. So, from personal experience, I've learned that the more small things that I say I'm going to accomplish, the small things start to add up to those bigger things. So
some of our conclusions. Basically, try to use rapid prototyping as much as possible. We like coming from ideas from real-world type thing, not just thinking of them being clever yourself, but here's a problem you have from pen testing, or here's a problem that you have reversing some malware, or here's a bug that you found. Go from what you need to get these actual jobs done as opposed to trying to think things through all at the beginning. Always use scripts. If you're doing something that's very tedious or painful while you're debugging or reversing, write a script for it. Make it useful, and then from there, it tends that the way that you're doing it works out better overall.
And so, in addition, we've introduced our Rebridge model. It's basically a distributed network or a distributed framework that's going to hopefully be a middleware that allows independent tools to integrate and talk to each other. Currently what we have is kind of like an alpha piece of software where it basically allows IDA Pro to talk to either one debugger or the other. But hopefully we would like to make this a little bit more interesting, where we say, okay, let's connect more elements to the party and see if we can't get more information being shared, more data being sifted through, so that way we get more interesting results. And the whole idea is also to enable multiple users to share on the same session. So something like Collaborate, but on a more heterogeneous playing field, where basically we're starting to incorporate frameworks such as Radar or BinNavi or multiple debugger types into a single distributed session. So some related work that we've experienced is, of course, Collaborate, which basically uses a central repo that maintains IDBs and allows users to make modifications and share those modifications out with others. So multiple users can actually connect and mark up the IDBs. Another one is BinCrowd, which is a product of Dynamics. Sorry, there's a bug there. And this is basically a repo where users upload comments and functions from IDA Pro. and then they can share it with others, and others can actually get the information that's already been shared or been revealed or identified by other people inside the crowd. So basically, people get to reuse the work of others. There's also another project that we took from Byakugan, which is a little bit different. It's actually a vulnerability visualization or vulnerability research and visualization tool that allows people to use Metasploit and WinDbg to create or speed up the vulnerability research process. And so, with that being said, we'd like to offer special thanks to SciPy for creating IPython, Chris Eagle and Tim Vidas for Collaborate, Deli and Hexrace for IDA Python, Postcat and Linux for Byakugan, and Visigoth and Conchoto for vtrace. If you guys are interested in the code or the presentation slides, you should be able to find them from the GitHub link here at Matt's account, so you won't be hacking mine.
Thanks.
So are there any questions or comments? We kind of blazed through that pretty quickly. Yeah. Okay. Right on. We're done.